as Richard said, a talk about fake data and our experience sort of generating fairly complex data for our use cases. Before I start, a little bit about me. I'm Eric, Head of Engineering at Tasman Analytics. We're a boutique data analytics and AI consultancy, remote first, but offices in UK and Netherlands. We're a friendly lot. If you've got any data problems or data questions, issues, come and find me. I'll be around the whole conference. With that out of the way, let's talk about. Let's get into it. So, this talk is really about helping you unblock yourself if you've ever come across a situation where you need some data, but you can't use or you can't access that data because it's got PII information, it's confidential, or it's just not accessible because it's in an antiquated system that we can't access. We often come across this problem, and we've developed a couple of tools to help us get through it. And really the way that we try and do that is by generating some realistic but very, very fake data. So the particular use case that I'm going to talk about is tracking user behavior on websites. So this is a very sort of traditional type of project that we would do. We've got like a lot of tracking knowledge in the company, and so clients come to us and ask to help them with implementing a tracking platform that will help them understand how users are using different features or parts of their website or product. And so the idea is that as a visitor moves across different pages and different elements of their website, that generates events that can later be modeled and turned into insights. So here's a very typical example of a user journey. So the top one, visitor starts with the home page, they then move to a services page, have a look at the blog roll, realize that they want to know a bit more, fill out a contact form, and hit submit. You can see some other journeys there, and sort of two things I want to point out is that there are many journeys through a website, and some of them aren't linear. And so we've got this like percentage breakdown between different journey types, but also a sort of percentage drop-off rate as well. So that it's not expected that everyone who starts at that first event will make it through to the final event, that people will drop off as they go through that journey. And so you have these percentage gates between each event type. All right. So the first thought these days is, can't AI just do this for us? Can't we just give it a prompt and get it to give us some fake data? So we tried that. We started with users because the user entity is quite a fundamental entity. The tracking is really about identity, like identifying who users are and how they're using your website. So we used an LLM to create some fake data. So create 5 user profiles with some attributes or properties. You can see, it's done a pretty good job. There are sensible usernames, the emails are consistent with the usernames, and devices all make sense, right? So that's looking good. Green check. What happens if we increase the number of users? So to create 100 user profiles, again, the same sort of instruction or prompt, and this time it generates a JSON file. Great, that makes our life easier. Now, we're starting to get maybe a little bit more complicated, but still, baby steps. So pick one random user and generate an event journey. So it does that, and we've asked it to use the RudderStack schema. Again, it's reflected that it's returned a sensible set of events grouped into a journey. You've got a consistent user IDs. So I think it's done a good job here as well. Now, what happens if we want to blow this up into sort of more realistic volumes of data? So again, starting small, let's do it for 5 users first, and 20 journeys per user. And here, I think we were using ChatGPT. It had to think for a little bit. And after a while, it gave us a result. But the journey was the same for every single user and doesn't really reflect reality. So we added some randomized drop-offs and got it to do that exercise again. Again, it was slow, and the 23 seconds seemed to take longer, close to a minute or so. But it returned results. And finally, let's actually do it for real. 100 users with a total of 1,000 journeys. All right, it's writing some Python code. Not the code that I would write, but it's going to give us a result. And the main aim of this exercise is really to generate the data. So how it generates that data isn't a huge issue. But here, you start to see some inconsistencies. I don't know if you can, yeah, I think you can see it. So, the list of devices it has include a smart TV and a smartwatch. And no one's visiting our page from a smart TV or a smartwatch. It also then starts to have some weird issues and artifacts about the user entities as well. So this was the moment when I thought, all right, I can either switch to coding it myself or continue down this journey. So of course I continued down this journey to see how far I could go. And really, 3 hours later, I came to the same realization I'd had at this stage. I think it's time to move to just doing it myself. So, yeah, sorry. I think, screw this, I'm going to do it myself. So what were the learnings? I think LLMs are really useful for this type of use case, but they have some limitations, and sort of primary to that is this notion that when natural language, when the outcome you're trying to get to is hard to describe in natural language, you need to move to a better form of describing that outcome. It could be code, it could be something else, but where LLMs really shine is if the data set is small, if it's not complex, if logical consistency isn't that big a deal. You might get usernames repeated, you might get inconsistent usernames in emails, but for a lot of use cases that's fine. And also the big thing was I was doing this to generate it for one particular client. But actually what we want is a process or a way of repeating it across all of our clients, because it's an issue that we face time and time again. Right. So Faker to the rescue now, pure Python. So Faker, if you don't know it, is a simple Python library designed for creating fake data. It's super lightweight and really easy to use, but there's a big caveat. The data isn't really random. What it is large sets of input data that it just randomly selects. So it has a set of first names and last names that it will randomly select from, and it will combine and return those. So there is a chance that you may get the same combinations in multiple times if you do it often enough. So how do you use it? This is how you use it to create fake people. Instantiate the Faker class, and then just call methods as you need them. So the name method, the email method, and if you really want an email from a free email service, super simple, but you can see that every time you call the name, every time you call the email, it gives you another random value. So it lacks that consistency if you use it in this way. You can also generate characters as well. So there's loads of methods here. You can generate random digits. You can generate random digits above 2. You can generate random numbers of a fixed length. You can generate random letters, lowercase and uppercase letters. You can generate numbers, and you can generate both numbers and characters. So it's super flexible, and the syntax is very, very simple. Super easy to get going with. And you can even extend it to text as well. So starting with words, sentences, paragraphs, and then any length of text. You can see that it doesn't make sense, but for a lot of use cases, this is perfect. One of the things that makes Faker really, really useful is this concept of providers. Providers are a logical grouping of data that you can bring into the main library and use in a similar way. So, it has all of these providers out of the box, and there's like about 10, I think, community providers as well with additional groups of data. So, you could have automotive data, you could have internet data, you could have currency data, and you just bring that in as you need. My favorite one that I found was this fake passports data. I thought, this is a JSON-born provider if I've ever seen one. You can generate dates of birth, numbers, owners, and even full profiles. So, you could easily create a fake person with realistic passport details. I just realized Mary Velez's passport is expired, so that one's not good, but other ones will be. Right, how did we use this? So after the LLM debacle, I realized actually the power of building this tool is if other people in the company can use it. So we drive this tool using YAML config, and the config has a global section which has parameters that are relevant for all journeys for a particular website. Like the website, the base URL, number of users, number of journeys, all of those sorts of things. It also has event properties which specify what properties each event may hold. And this is just a sense check to make sure that these event properties, that the events are using canonical event properties and they're not just random. People aren't just randomly implementing events without thinking about what properties they want to track. Events record, change of state as a user moves through a website, and journey pathways group events together in an ordered fashion. So this is what the event specification looks like. So you can see there are unique event IDs, so login, homepage view, services page view, and each of these events have properties that have been specified in the properties section above, and they can be of two types. So they can be hard-coded, and they are, for example, the login event is triggered the login path of the URL, so that's hard-coded. But the user email and user company username, these are fake details that we want to replace at runtime. So these are placeholder values that are then replaced later. And then journeys map out that sort of visual I had before about the sort of journey breakdown across all journeys, and then also the percentage of people that get from one event stage to the next. So this is a fairly complicated bit, but it allows us flexibility and it allows us to introduce some variation in those journeys. So that, which replicates the real world scenario where people aren't always going through a particular path. And then we wrap all of that up into wrappers. So these wrappers are different for different platforms. Different platforms will capture different data as default. And so we've got a RudderStack wrapper here which has a hell of a lot of data, and actually the event data is highlighted by the orange arrow. Everything else is captured by the platform or by the SDK and sent to the platform. And so you can see with the white arrows, this is where we're substituting in the fake data, and some of that data is specific for all journeys, some of it is specific for a session, some of it is specific for a specific user or their device. So there's a lot of, all of that fake data that's set up previously is then substituted at runtime. We also created some providers to give us some logical consistency between different entities. So, for example, we've got a user provider, and I felt it was really important that our fake user has a real email address based on their company name. And so here Kathleen Price, who works at Lawson, Vargas and Palmer, has a realistic email address with what could be that company's domain URL. And so this provider is a way of us then making sure that all of the properties that are assigned to an entity make some kind of logical sense, and it's something that you could actually run some analytics on. So for example, if you're grouping people that come from a specific company, like you could do counts across how many users are coming from that particular company. Yeah, and we use this for other things as well, like devices. So for example, we've got Kathleen's iPhone, which was how she accessed the website. It has, it uses iPhone OS 10.3.3, uses iOS, and it's on mobile. So that you don't get that consistency if you were just sort of using the default providers and just generating fake data. In this instance, it was useful for us. In other instances, it may not. Right, and so what does that look like? So this is an example of the data set that we generated. This is Mackenzie Wolf, who has visited the website on multiple occasions in different sessions. You can see on the 4th of August 2025, they landed on the homepage, looked at the blog page, read an article, read a services page, viewed the services page, and then left. They returned later that evening at 6 p.m, wanted to learn more about the homepage and read the blog page again, and then left again. So you can see that there is this consistency of journey pathways in that they are starting in the homepage. It could, of course, you could have journeys that started elsewhere as well, but the journeys that we specified, they all started the homepage. And you see also that this could probably be the same journey, but the first time Mackenzie has visited the website, they've gone through to the service page event. Second time, they've dropped off after viewing the page, which is quite common when you're looking at user behavior on the website. And finally, again, another visit on the 5th of August. But what I want to sort of draw your attention to is actually this was part of a 3,000 record data set. The data was generated in 1.5 seconds, and actually the full run time of that of this instance was 4 seconds. So it was actually 3 seconds to write it up to the cloud warehouse. Much faster and much more repeatable. And so I guess that takes me to learnings from Faker. So, when should you use Faker? So Faker is great for data generation that is complex, and you need it to be highly consistent. The benefit is if you specify by code, you can be as specific as you need, and also you can run it as often as you need, and it also opens up the opportunity for other people to collaborate on the code base. You also have the opportunity to, it's almost a foot count because it's so easy to use. You can generate as much data as you want, and it becomes something that anyone in the company can actually use themselves. And so that's it.
Thanks, Eric. And now is a great time for questions.
Hello, thank you for your talk. I have a question about the engine that runs the random, like the pseudo-random sampling. Is it NumPy or something similar?
No, it's even simpler than that. It's the base library. It just uses random, which is a core library.
Yes.
Yeah.
Oh, then you can set then the seed and to repeat your experiments. Oh, that's great.
Yeah, you can set seeds. Yeah, for sure.
Thank you.
very interesting was looking at the example, and you could see how it was spending time on each page, which is obviously got to be quite random. So how do you ensure, it was good to see it was consistent because it made sense. How did you define those different journeys? Because obviously, as you explained at the beginning, there are infinite number of potential ways you can click through a site. And particularly for a more complex site, how do you control that growth of data?
Yeah, it's a fair question. So the journeys are sort of specified through the YAML. And so here you can, these are all linear journeys, so it starts with one page, goes to the next, goes to the next, goes to the next. But actually, a lot of user journeys are non-linear, so they go to one page, then go back to the first page, go to another page, go back to the page. At the moment, that is something that would need to be hard-coded through the YAML, or specified through the YAML. And the way that we handle the sort of randomness of people dropping off is to just generate a random value and compare that against the threshold to work out if someone's going to continue, then that random value has to be greater than, and if they're dropping off, then it's less than that ratio. So yeah, so that's how we handle it. It's a little bit of a fudge, but you know it's good enough for this sort of situation.
Thanks so much. Looking at this from the ethical use perspective, for someone who is building a product and is trying to leverage the solution to build something, even when you're not using it to build a production thing, but at some point things might be similar to what you have in real life. As someone who wants to use this product, do you think it's okay to have like a disclaimer to say for every use we are using a fake app? Does the audience need to know? That's essentially the question. Does the audience need to know that you're building something, whether a prototype or almost fit for purpose product? Does the audience need to know that you're using a fake data to produce something just to show that it's possible? Or once you take this product, it's already there, you can use it any way you want?
Yeah, so the caveat is that we really use this as an internal tool where we don't have access to the data. And so, you know, the data modeling and stuff that we do is just, let's say, a way of unblocking ourselves, because, you know, if we're waiting for the full implementation to finish, it could take months. And so this is really a way of us generating some fake data, being able to do some data modeling, and then when that real data is available, we will swap out the sources. So then the models will actually run with real data. So anything that the client sees, we caveat with this is all fake, but it's here to just to give you a flavor for what insights, what insights you might be able to get from this data and how that looks when we do visualizations.
A lot of what you talked about was about data consistency and sort of self-consistency between the models. This might not impact your use case much, but it'd be interesting to hear if it has. Real world data is often messy. You get users sign up with email addresses that don't match their company domains, or they've used their personal email, or they've entered their date of birth wrong, stuff like that. Do you have any experience with altering the generation so that there is that kind of noise or incorrectness in it?
No. It was hard enough to get it consistent, so I didn't go the other way. But I think the way to do it there is to really use the existing providers, but introduce an element of randomness. So I use the random library quite a lot to add additional jitter, and so that is a useful way to sort of to introduce that randomness. You can also sort of set up your own provider and your own sort of input data as well, that you can then mutate yourself, you know, and like randomly drop out, you know, surnames from username field. Yeah. So for example, every user has a first name and a last name in this instance, when actually we know like sometimes the full name is in the first name field, sometimes the last name doesn't exist. So yeah, it doesn't capture that element of the of real world data.
Thanks, Eric.
Thank you.